My name is Steve Mwaniki. I'm in charge of ESG, that is Environment, Social and Governance at the group level. I'd want to take you through our constructed wetlands. The constructed wetlands is a project which has been undertaken to sustainably treat our wastewater, which is a sustainable way of reusing the wastewater generated by our operations. In this project, we have several ways of collecting the effluent or the wastewaters. We channel all the water enclosed in a pipe into these wetlands. This is where we have all the effluent being collected. As I mentioned, is a primary waste holding tank. And we also have the NEMA sampling point for the upstream. So this is a grossly polluted waters, which comes to the first primary holding tank. The second portion is the secondary holding tanks. The first thing what it does is to hold the water to ensure that we have continuous supply of the water into the GBH as well as the ponds. So this is our GBH, or rather horizontal vertical flow bed. So here we have a substrate which is gravel, and the wastewater will go in a zigzag way just to ensure that it takes the longest time possible. We approximate that a water molecule will take about 14 days to run from start to the end. Inside there are some plants. What you can see here is sedge. We have some arrowroots, and also we have some canna lilies, which are being grown on top of the GBH. This is the exit or the end of the gravel bed hydroponics. And here we have the control plant, which is called the water lettuce or Chinese cabbage. And this plant we use to check exactly how the uptake of the nutrient is. Then from the horizontal flow bed, we have the effluent moving to the first service cell. From the GBH, the water is now out in the open, and we introduce them to the first cell. And this specific cell, as you can see, there is a lot of plant cover. We have what we call the water penuate, which is sitting on top of the water. It's actually literally floating on top of the water. And we have the cattail plants, which are on the side. On the extreme end, we also have arrowroots, which are very good in removal of the heavy metals from the waters. The water will flow from service cell number 1 through gravity to service cell number 2. We ensure that we maintain young plants, because naturally young plants will feed much faster than the old plants. From service cell number 2, you start seeing frogs, 3 and 4 and 5. But for us, we've introduced fish at the point of service cell number 4 and service cell number 5. At service cell number 5, there are some specific plants, or in this farm, we use what we call the Chinese cabbage. So this is a plant which, the same species, Nile cabbage, which is growing on the 5th service cell. It has long roots, long fibrous roots, meaning it's struggling to get nutrients. Therefore, we know that this water has very less volumes of nutrients as compared to the same plant at the end of the GBH, which has very, very short roots. That tells us that the water at the service cell number 5 has less nutrients. And therefore, we know that all the fertilizers, all the plant protection products have been uptaken upstream by other plants in service cell number 1 through to service cell number 4. And here what we do is that we allow the water to come in, and then we take sample to the laboratory for actual confirmation of the ingredient or the composition of the water. That is the story that we are giving you today, that in Marginpar we are able to reuse all our wastewater.